Hello friends, today we are going to discuss the very interesting program of finding whether a number is an Armstrong number. So, Armstrong number is a special number which is the logic of which I will just let you understand. If we take one number as if 125, 145 or say 153 and so on and so forth, any number you can take, it is a whether it is a 2-digit number or a 3-digit or a 4-digit or 5-digit and whatever may be. We are taking, for the sake of simplicity, we are taking a value of taking three different 3-digit numbers. So let us see this 125. So Armstrong number is that number which is the sum of the cubes of the individual digits of the number. If that sum becomes equal to the number itself, then the number is an Armstrong number, which was this was discovered by Armstrong and named after him. And say suppose let me explain you in detail. See this 125. 125 has got 3 digits, 1, 2 and 5. So this 1 when cubed becomes 1. When 2 is cubed it becomes 8. When 5 is cubed it is becoming 125. So let us just add these 3. 1 plus 8 means 9 plus 125 is 134. So 134 is definitely not equal to 125. So 125 is not an Armstrong number. Suppose we just do the following calculations in case of 145. This 145, 1 is cubed, 4 is cubed, that is 64, 5 is cubed, that is 125. So 125 and 65 gives you 190, which is definitely not equal to 145. So 125 is not an Armstrong number, 145 is not an Armstrong number. Let us check this third one. See this 1 cubed becomes 1, 5 cubed becomes 125, 3 cubed becomes 27. So let us add up these 3. 126 plus 27 is equal to 153. So we have found a match now. So this 153 number is just equal to the sum of the cubes of the individual digits of the numbers. So this 150 is that Armstrong number which we were trying to find. So there are many possible Armstrong number in the sequence, but this is the first Armstrong number starting from 1, that is the 153. So this 153 is the Armstrong number. So in this case, if the user gives the value of 153, definitely the output of the program will come like this. It is an Armstrong number. If the user supplies 125, the output will become it is not an Armstrong number. So our objective is to determine whether any number input by a user is an Armstrong number. So for this case we are using the while loop logic. So now let us get started with the program's first line. We have declared some variables for the purpose. That is, we have taken one variable as n, one variable as r, one variable as x, and one variable as sum, which we initialized to 0. So this program is quite reminiscent of the previous program which I have done in a previous class. That is the sum of the digits of a number. That was an illustration of the while loop program which we have dealt with earlier. So this program can be just compared to that program. So if you just have an understanding of the sum of the digits program, you can get to this program as well. You can get to know this program as well. So this is the variable declaration section, input section, and then interesting thing is something like this. This line is to be taken into consideration. This is a very important line. See why this has been done. You can just get it in the later stages of the program, but for the sake of your understanding of the entire program, we will just address it now on. So see, let us see why this x is needed. X is nothing but an auxiliary variable. Auxiliary means something which is helping, which is a helping variable, and this n number, in the course of the calculations, suppose we have to check the sum, we have to tally the sum with the original number n. So if the n number becomes updated in the sequence of the iteration, then the original number will ultimately become less than it will become less than 0. Then it comes like this. the number will be never be equal to the original number. The number will be updated. So as long as the number is greater than 0, it will be executed. This loop will be executed. When the number becomes less than that, we will come out of the loop. So in the course of just coming out of the loop, we will update the n number by these 3 lines. So that will make us quite difficult for us to determine whether the original number tallies with the sum. So how to deal with that situation? That situation is being dealt with by taking a third auxiliary variable. This is the auxiliary variable x, which will take up the original value of the n, and it will store the original value of the n, which is to be checked in the later part of the program to determine whether the number is an Armstrong number. So this x is taken to just store the original value of n, so that we can keep the track of the original number which was supplied by the user, so as to determine whether the number is Armstrong by checking the sum, or whether the number is equal to the sum, so as to determine whether the number is an Armstrong number. So this x is the helping variable which helps us to store the original value of n, because in course of our programming logic or calculations, we will just go to update the n, and the n value will be changed. So now comes the while loop. So whatever will be the value of n, suppose the user gives 125, it will be stored in x. So x will just take up the value of the original value of n. Now we are seeing that while it is to be written like this, while n greater than 0. So as we have got this logic, Armstrong number logic, we now go towards the program execution part. So this program starts with this line, some variable declarations. N is the number which is to be supplied by the user. R is taken to be the remainder, taken for the remainder portion. X is an auxiliary variable which will be discussed later on. Sum is the sum of the cubes of the digits, which is to be taken in the sum. So this program is quite reminiscent of the previous program which we have done in a previous class, when we went on to describe the while loop. In that program we described the sum of the digits of a number. So this program is somewhat similar to this sum of the digits program of the while loop, and this program is quite similar to that. So you can refer to that program in order to get a better understanding of this program. So you can just go to the previous video and see whether you have understood the sum of the digits program properly, so that you can just get this program in a very easy manner. So let us now start explaining. So this is the input portion. This enter a number, ampersand d, scanf ampersand d ampersand n. Nothing to explain over here. Now the programming logic starts from this line. This is this line which is pointed to by an arrow. So this line is the first line of the logical sequence of the program. So x, what is x? So the number, as you see in the sequence, of the calculations, in the sequence of the program development, the n number, which is the original number input by the user, is being updated step by step. In each of the iterations of the while loop, as we have done in the previous program also, the n will be updated until it becomes 0. So when the n becomes 0, the while loop, we just come out of the while loop and go to the next expression statements, whether those expression statements to execute or not. That should be determined, that should be done only when we come out of the while loop. So this n will constantly change, so it will make our life difficult to understand whether a number, to determine whether a number is an Armstrong number, because we have to just tally, or we have to just check whether the original number is equal to the sum of the cubes of the digits. So if the n value gets destroyed, if the n value gets updated and ultimately becomes 0, so everything will be compared to 0 and it will not become equal. So no number will be determined to be an Armstrong number in the entire set of integers. So that will make our life a bit difficult. So for that situation to be dealt with, for handling that sort of situation, we have taken a variable which is x, and x will contain nothing else but the value of the original number n, which was supplied by the user. So suppose the user will supply 125, though, so the n value is 125 at the very beginning, and x will also contain the same value, that is 125. Now we come to the next line, that is while n greater than 0. So as long as n is greater than 0, or as long as n is a positive non-zero number, we are going to just iterate through this looping sequence. So now we come to the first line of the while loop statement, that is r is equal to n%10. That is quite similar to the sum of the digits program, as you can recall. So r is equal to n%10 means r, he is assigned a value which is nothing but the remainder of the number which when divided by 10, because we are dealing with all decimal numbers, so 10 will be our radix, and so this 10 will divide the n, whatever will be the remainder will be stored in r, and that will help us to take this last digit, that is the unit place digit. So that will be stored in r. Sum has an original value of 0 which was initialized beforehand. The sum will be then updated by this calculation. What is this written over here? Sum plus pow bracket r comma 3. So this is an interesting part. What is this pow r comma 3? So pow r comma 3 is nothing but a mathematical function which is included in the header file math.h. For that we have used a special header file inclusion statement. Apart from the all other programs in which we use normally hash include stdio.io.h, we have used another preprocessor directive over here, that is another file inclusion directive, that is hash include math.h. So math.h contains this pow function. Pow is nothing but the power function. Power function is to calculate in this manner. Suppose this pow r comma 3 will be returning something like this. This pow function is a library function and it will return something like this. Say this value of r, suppose this value of r is 5, and this 5 comma 3, when it is inside the pow function, the pow function has these two parameters, two arguments, and this 5 will be raised to the power of 3. So 5 will be raised to the power of 3, that is 5 cubed, that is 125. So this pow r comma 3 will be calculating the value of these arguments supplied in the brackets, and these arguments will be calculated in this manner, that is the first argument raised to the power of the second argument. So whatever is the value of r, that will be raised to the power of 3, that is r is being cubed, and then that r cube is added to the sum, and the sum is now updated. So and after that we need to change the n value in order to just advance further. So this n is calculated in this manner. N is equal to n/10, so which gives nothing but the quotient of this calculation. N when divided by 10 gives a quotient of some value which goes inside the value of n, and then n becomes updated. So n, the original n is now not with us. N becomes updated. So that is why we have taken this x value to store the original value of n. So let's just put some values in this n values in order to make you understand the program in a very clear manner. Suppose we can take this value of n to be 125. Suppose this 125. So this while n greater than, so x has a value of 125. Now we come to this statement while n greater than 0. Definitely 125 is greater than 0. We enter the while loop. We determine this r. So n%10, 125%10, n%10 is obviously 5, because 125 when divided by 10 will yield a remainder of 5, and so this r value will become now 5. So now this sum is equal to sum plus pow r comma 3. So what is this pow r comma 3? Pow is something, it is a mathematical function. It is a mathematical function as we have discussed beforehand, that is pow 5 comma 3 means 5 raised to the power 3, pow r comma 3 means r to the power 3, and so on. So our r contains the value 5. So this statement now yields what? Sum means 0 plus pow r comma 3 means 5 to the power 3. So sum becomes 0 plus 5 to the power 3. So that is 5 to the power 3 is 125. So 0 plus 125 is equal to 125. So Now the sum contains the value of 125. N is now updated. N is now updated as n/10. So n/10 will definitely yield you 12. So n now will have a value of 12. So we come to the while loop once again. Let us see whether we can enter the while loop once again. While n greater than 0, yes, the condition holds because n is 12, which is definitely greater than 0. So we enter the while loop for the second time and we calculate in the same manner as r is equal to n% 10, that is 12% 10 will give you a result of 2. So r will have now a value of 2. So now this calculation, sum has originally the value of 0, which was updated to 125 in the last iteration. Now sum has a value of 125. Now power r comma 2, power 2 comma 3, power r comma 3 means power 2 comma 3, that is 2 raised to the power 3, that is 2 to the power 3 means 8, that is 125 plus 8 is nothing but 133. Now the sum value is updated to 133 and then we will again try and update the value of n by this calculation. So n becomes 12 by 10. It is nothing but the quotient is 1. The quotient is 1. So let us see whether we can enter the while loop for the third time or not. Yes, we can enter because n is 1. Still n is greater than 0 and we enter the while loop once again and do the following calculations once again. So r is now n% 10. R is now updated to be 1% 10. The remainder will be 1. Sum is equal to sum plus power r comma 3. Sum is now containing a value of 133 as has been calculated here. So 133 plus r comma 3. R has a value of 1. 1 raised to the power 3. 1 cube. 1 cube means 1. So 133 plus 1 becomes 134. So 134 is the result of the sum now. Now again we update this n value. N is equal to n/10, that is 1/10. Obviously the value will become 0. Now let us try and see whether we can enter the while loop or not. See, n has a value of 0 now and this condition never holds. So we come out of the while loop and come to this expression statement which checks if sum is equal to x, if sum equals x, that is sum is now 134 and x was nothing but the previous value of n which the user supplied, that is 125. So 135 and 134 is not equal to each other. They are not equal to each other. We will then print it is not an Armstrong number. So we go to this else portion and print this. It is not an Armstrong number because those two numbers doesn't match. If it matched, had it matched, we could have printed it is an Armstrong number. But the case is not like that. But let us see in this case. So let us just go through this case. 153, we go just like this, the dry run will proceed like this and this 153 will yield you what? Ultimately the 153 will yield you the sum of 153 and x will contain 153 then. So if sum is equal to x, if sum equals x, this line holds in that case. So 153 is the sum, x is also 153, so this condition holds. We print it is an Armstrong number. See, this 153 is an Armstrong number and 125 was never an Armstrong number. So that is the for the better understanding of the program. We have taken some values, sample values, and made a dry run in order to make you understand this Armstrong number logic, Armstrong number program. So if you have any doubts or queries regarding this program, you can just put your queries or doubts in the comment section below so that I can just address to those. Thanks.